Hey, you are watching AliAziz YouTube channel.
PAS, PAS-AB, and PAS-D staining techniques. AliAzizQualityEducation YouTube channel provided you the medical-related topics videos. So don't forget the subscription button. In the field of histopathology, staining techniques are indispensable tools that allow scientists and medical professionals to visualize and differentiate various cellular components. Among these techniques, periodic acid-Schiff, PAS, staining and its variants, PAS-alcian blue, PAS-AB, and PAS-diastase, PAS-D, are widely used. Each method has unique applications and reveals specific aspects of tissue structure and function. This article explores the differences between PAS, PAS-AB, and PAS-D staining, highlighting their distinct purposes and the nuances they bring to histological analysis. Periodic acid-Schiff, PAS, staining. Purpose and application. The PAS stain is a versatile technique primarily used to detect polysaccharides such as glycogen, mucosubstances like glycoproteins, and glycolipids in tissues. It is particularly valuable in diagnosing various diseases, including glycogen storage diseases, certain fungal infections, and conditions affecting basement membranes. Principle. The PAS reaction involves oxidizing tissue components with periodic acid, which converts 1,2 glycols to aldehydes. These aldehydes then react with the Schiff reagent, resulting in a magenta color. This coloration highlights structures rich in carbohydrate groups, such as the glycocalyx, basement membranes, and some mucins. Key features. Visualization. PAS staining produces a bright magenta color, making it easy to identify structures containing polysaccharides. Diagnostic use. It is commonly used in renal pathology to assess the integrity of glomerular basement membranes and in liver biopsies to detect glycogen storage diseases. PAS-alcian blue, PAS-AB, staining. Purpose and application. The PAS-AB staining technique is a combination stain that differentiates between neutral and acidic mucins. It is particularly useful in the study of mucinous substances and in identifying various types of epithelial cells in the gastrointestinal and respiratory tracts. Principle. This method involves two staining steps. Alcian blue, applied first. Alcian blue binds to acidic mucins, staining them blue. Acidic mucins contain carboxylated and sulfated mucopolysaccharides, which Alcian blue highlights. PAS reaction. After Alcian blue, the PAS reaction is applied to the same section, staining neutral mucins, glycogen, and other PAS-positive substances magenta. Key features. Differentiation. PAS-AB staining allows the differentiation between acidic, blue, and neutral, magenta, mucins, providing detailed information on the composition of mucus. Diagnostic use. It is helpful in diagnosing mucinous tumors and diseases characterized by abnormal mucus production, such as certain cancers and inflammatory conditions. PAS-diastase, PAS-D, staining. Purpose and application. PAS-D staining is specifically designed to identify glycogen in tissue samples. The inclusion of diastase, an enzyme that digests glycogen, distinguishes this method from standard PAS staining. Principle. The process involves two main steps. Diastase treatment. Before staining, the tissue is treated with diastase, which digests glycogen into smaller sugar molecules that are washed away. PAS reaction. The tissue is then stained using the PAS method. Since the glycogen has been digested and removed, only structures containing other PAS-positive substances, like mucins, will stain magenta. Key features. Specificity for glycogen. The key feature of PAS-D is its ability to differentiate between glycogen and other PAS-positive substances. After diastase treatment, a lack of magenta staining indicates the presence of glycogen. Diagnostic use: it is particularly useful in distinguishing glycogen storage disorders from other conditions that may also show PAS-positive staining, as well as in studying various metabolic diseases. Conclusion: PAS, PAS-AB, and PAS-D are essential staining techniques in histopathology, each offering unique insights into tissue composition and pathology. PAS staining is a broad tool for detecting polysaccharides and glycoproteins, crucial for diagnosing a range of diseases. PAS-AB adds another dimension by differentiating between acidic and neutral mucins, enhancing our understanding of mucinous secretions and their role in disease. Meanwhile, PAS-D is invaluable for specifically identifying glycogen, aiding in the diagnosis of metabolic disorders. Each technique serves a specific purpose, and the choice of method depends on the diagnostic question at hand. Understanding the differences and applications of these stains allows pathologists and researchers to select the most appropriate method, ensuring accurate diagnoses and deepening our understanding of various diseases. The delicate art and science of staining continue to be a cornerstone of histopathological practice, illuminating the microscopic world with clarity and precision.